Hey again. My name is Simon, and in this video I want to show the core of the product I'm currently building. If you missed the previous videos, it's about a Flutter admin dashboard, so built in Flutter, and it works on Flutter Web, but should work as well on all the other supported devices. Let's have a look. In the dashboard, we have some views over here, and we can switch the primary navigation to the CRUD models view here. So this is the list of model instances that we can work on, and we might switch to create such an event. And we also might switch to the account page. And when you look down here in the admin debug panel, I added, just for us to understand better what is going on, we see that we have some stack here that is building itself up with all the views that we just visited. So down here we have the dashboard and the events next, and the account page on top, which is the page that we're currently actually viewing. Now also notice that up here, while I'm navigating, the URL changes. When I go to dashboard, this changes. And of course it works also when I type something. That's what you expect from a website, isn't it? But it's actually harder than you think to get that right and to get it kind of extendable, because I felt it's super easy to shoot yourself into the foot when doing navigation with Flutter. Now let's have a deeper look why it's complicated and how to solve it, in my opinion, with the new way that Flutter offers the Navigator 2.0. It's basically the new way in declarative routing. It's optional to use, but I used it and I like what I achieved with it. So in the last video, we already saw some global state and how the state is connected. Last time we saw that the core state to do everything related to views and what gets displayed is in our view stack. A stack which contains all the views that are currently layered. What does it actually exactly mean that they are currently present and in this layered stack? Well, to understand this, we have to understand what stateful widgets are, because Flutter has some optimizations to reuse widgets when they are stateless. When they are stateful, they can keep their own state and the state is not lost as long as this widget is potentially seen on any page. Now, you might have noticed before when you did some Flutter projects that when you go to, for example, a form, actually the only form in my interface currently is the login form, so I will just sign out for a second, sign in again. Such a form, for example, has to use some state because it has a text controller as an example, or also a focus scope that controls temporary information related to that form here. And you can notice that this actually is not maintained forever, that state, by typing something here. And when you go back to another page, for example this one, and then turn back again to the account page, our fields are empty again. In this case, I actually think that's desired. But when it comes to navigation and our stack, it's not desired. We want to have full control over it, and that's why I keep it in global state. I use the package riverpod, and this series is mostly about how to integrate a Flutter application nicely with that library. So riverpod, just as a repetition, is just similar to the provider package, which is very popular too, but it adds some extra type safety. And for my taste, makes it super hard to operate your application once it's integrated. So the stack down here in declarative routing will actually be present all the time. So it means Flutter is not just knowing about the top layer and about the widgets on it. It's knowing about all the layers below as soon as we have more than one. So in this case, the widgets that are now hidden, not visible on the dashboard, are still present for the Flutter build logic. This means if there is some stateful widgets on the dashboard, it is preserved for us. So that's the reason why it's better to have one representation of your layers and one global state. Now, last time we also saw that we use some connectors between states. They're usually done with the watch method on widget refs. And we saw last time that in one of those events that can trigger such a state update is basically when somebody enters something into the URL bar. That's like a user event similar to a button press, and it will, every time this happens, it will induce a state update on this one. And this one again will influence others, and the symbol we said is that there are indefinitely many state updates flowing down this DAG. From the URL bar, we, for example, have the not found path that we can set to something if there's something that is not resolved. And this influences, for example, the main view displayed. So the main view is just a subset of the state of the view stack, also using some information from that state. There is actually a line missing. I think I forgot this last time. So basically we said that in some way this of course has to influence the view stack as well, because it's not just a not found page, it's also the view stack itself that gets built up from the URL. So when this changes, we have in declarative routing the option to completely derive our view stack that we desire. So it's not like that you just push and pop layers and the actual stack is kind of internal to Flutter. No, with declarative routing, you have full control above which layers are on your stack, and with this, which state is maintained. Let's look at the key point in code for that page stack. Now, in our main file, the main file you find just in the lib package. Oh, and by the way, if you want to follow along, you find all this code on GitHub. It's a quite permissive license as well, so you can follow along, you can use it for your project. Just go to github.com/smartnuance and flutter-admin-kit. So in the code, we want to look at the main point where these page stacks get built up. And let's not be confused for now with all the different kind of classes we need for it, but at some point, we see that interesting navigator here. That navigator is an element from Flutter, so it's not my own. So this one is how you do it for the new way to do the navigation, or the advanced way. It's actually still optional to use that one, I said. So in this navigator is just a widget, and it takes that interesting argument here, which is a pages. So this pages is a list of material pages, or actually any, it can also be derived from pages. And this, so we see it here, it's a list of material page, but just because I defined it like this, yeah, the usual type, the required type is just a list of pages. And this page list is the key to like what state is maintained during the life cycle of your full app. Now, this page with riverpod, we can derive by our own custom logic from any state actually that we want. But when you see where it comes from in this code, it's actually coming from the view stack. The view stack is read up here with the watch command. So this makes the view stack variable here, the value always update whenever the view stack provided changes. That's what we want. And the view stack then influences which pages are landing into this list. So basically, Flutter has a certain concept, how this declarative routing works, and what I try to achieve is to connect it with my global state. And then I do all the manipulations no longer directly with Flutter commands, even though it would be possible to let Flutter do parts of it. But I do all the manipulations on my own definition of a view stack, which has the advantage that I can fully control extra information assigned to each stack entry. And I can also do stuff like I can relayer things, I can move one layer up, or I can delete a layer below if the state should be destroyed. And I can do all of this with the abstraction of pages or of layers. So we have the usual run app command, and in the brighter scope is for riverpod. It's like one of the widgets at the very root to actually enable all this watch functionality that you can use inside your consumer widgets. Now the admin app is my own class. It's a consumer widget as well. We'll see why in a second. And now the key point is down here in the build method. We're actually returning, an material app router. So that's how you choose the new navigator to the declarative one. This material app also has another constructor. That is the default one. Now this changes a little bit what arguments you need, and the two ones that are important here is the RouteDelegate and the RouteInformationParser. They're both required, and the RouteInformationParser is the one that we start with. It's easier to understand. So the RouteInformationParser is just a variable I defined up here. So it is basically derived from a class from them, and it has two main methods. It's like parse route information and restore route information. And this is exactly what it says. So basically it's the way, the point where I can translate the incoming URL into here, the incoming URL into whatever I like. We'll see in a second. And this is the opposite way. It's restoring the URL, as we have seen before. When we switch away, it's restoring the URL in something I want. And this can depend again on any other state. Now, how do we pass that back? It's a feature of a RoutedView. What's that? So RoutedView is actually my own object. It's an immutable state I create via freezed, and we'll see that in a second. Now, let's have a short glimpse on how this looks like, and it's quite what you would expect. This could be definitely also written in a more elegant way, but for now, for demonstration purposes, it's as simple as it can get. We're basically splitting our path and going conditional over their elements to decide what to return. And when we look at what actually gets returned in the end, that's the interesting part. We have some intermediate object, and in the very end, we return such a RoutedView, which has some factory constructors, but we see that in a second. So let's jump there. Now this RoutedView is my own object to track the view, at least what the full delegation and URL resolving logic has to know about. So RoutedView is the minimal thing to know for the communication between the browser telling me that something changed and my other app logic. Resolved means we in principle know which view to display, but we did not resolve anything else. We did not do any loading. We did not do checks if that is actually possible to show to the user that is authenticated. And loaded is then actually when we have it fully loaded and we can show it. And that is our third one, which is not found. Now, the not found one has the simplest arguments, just a path, the one that was not found or could not be translated neither to a view ID nor a fully loaded view, of course. So back at our main file, we now want to have a look at the other argument that we are passing here. As we said before, the main interaction between our logic to handle navigation and the Flutter built-in machinery is these two objects. That one is solely for the translation from the URL in some custom object for ours, and back from our custom object to the path that should be set. The RouteDelegate it's separate basically because the RouteDelegate is for the actual changes of state that we, for example, reflect in our global state, but also because the RouteDelegate can do something like popping a view. That is something that the navigator of an app should know about and should know how to handle it. So basically, RouteDelegate is more than just a URL translation. You will see in a second. So let's look at the object. Let's see this later, why this is actually provided by our global state itself. We guess it in a second. So when we go inside here, you see, let's look at the basic structure first. Like, you have a build method, and this build method is pretty simple. It's basically where you plug in this page stack. So in this URL navigator, finally we have our pages with the views. So all this logic handling state updates related to navigation is basically wrapped around our actual page stack. Now, the interface for this interaction is twofold. You have once everything that comes in from the Flutter machinery telling us that there is a new route that we should handle somehow or reflect in our state. You could count this as well. It's maybe like the middle ground here. So this is when Flutter actually asks us for the current state. So it tells us, hey, there's a new change happening. Then it asks us, what is the current state? For example, when it starts up the first time, we'll ask us what is actually the current configuration. Notice that this all is our own custom object. So basically in this one, Flutter is just replaying the thing to us that we actually parsed into our URL. But well, this RouteView might actually originate from somewhere else, and not only from a path. Now the other side is that we have to inform the Flutter machinery when we have a state update that is happening autonomously. It can happen from anything like a button press or time-based, or an API response wants to introduce a change of navigation. Why not? And this is done by these two methods. This is basically the change notifier interface. This is usually without riverpod implemented by using the change notifier class, but this is now the way how we glue together this with our riverpod notification system, kind of. So these two methods are also coming from the indirectly extended listenable interface. So this listenable interface requires us to implement the add listen and remove listener. So Flutter has a way how to tell us that they want to get informed about an update considering navigation. And let's look at those first. So this is the easier part. Actually, it took me quite a while to figure that out, but once you have it, it's actually easy. So it's not well documented, or it's maybe documented, but I didn't find good examples about it. That there is not only the watch and the read method on the ref, on the provider ref base, but also this listen method. And this listen method allows you to plug in imperative code. Basically, it's more like the usual notification happens. So you can say this provider, I listen to changes of this provider. Whenever it changes its value, we want to have whatever listen is called. And this is exactly what the change notifier does as well, where it's like a list of where change notifier just keeps a list of listeners to notify when a state change happens. This is exactly the same. So we're listening to changes here. The difference is that we don't really keep explicitly a list about our listeners, but we can, this listen function returns a console function where we can cancel this subscription, and we actually just simply save it here in our stateful widget. So we can do that And over here, when Flutter asks us to remove the listener again, we just cancel this subscription, which makes riverpod remove that listener and no longer inform Flutter when this main view provider changes. And notice that we are listening to the main view provider. Here, might actually also listen to the view stack, because the view stack changes whenever the main view changes, but the main view is the one that is influencing. So I guess it's here clean to say that the URL depends directly on the main view. So actually, if the main view later might change without the view stack changing, this is the better thing. So we might have some temporary things just in the main view, I don't know, a dialog or something, and the view stack is still the same. So it's better to rely on this one. Then we have the other side of the game, which is Flutter giving us new routes. New routes so they're not coming as paths here. So as we said, they're already parsed into our custom object, but they expect us to reflect that in state. And as you saw here before already, we need, for all of this handling, we need a ref. Since we are not in a provider inside here, we have to get that ref passed to us. And that is the reason why this ViewRouterDelegate has to be provided itself via a global provider. So the setNewRoutePath uses that ref to do updates on our state. So whenever the configuration, the RoutedView configuration, Flutter, we actually ourselves pre-parsed into this RoutedView, did some analysis on the path already, then we are getting it here and doing this freezed way to switch over the different possible values or states. It's resolved is the one that, no, the loaded one is the one that is the good case. So we read our view stack provider and switch to a certain view. Actually, when it's just resolved, we're actually gonna try to look it up, like with the UI configuration, which configures all of our UI. We are trying to look it up, and if it doesn't work, we actually setting the not found path. Now, we had said that this ref is provided by a provider, and let's look at this. I think we had it before, but when you go here to see when this is coming from, so basically it's not directly instantiated by the widget that needs it, but it's provided by this RouteDelegate provider, which allows us to get a ref and pass it to that object. So note that this thing is never recreated. It's just created once because it's the most basic provider type, which constructs this on the first access of that global variable and then never destroys it actually, and also never recreates it. So with that, we understood how navigation is connected to global state when using riverpod. And in the next video, we want to look at authentication, also with connecting state to global state to local state, because in the authentication, we will do the first form handling, and form handling is related to managing global versus local state. See you there.